Hi, welcome to my channel. This is an interesting limit problem, and one of the main topics in calculus is understanding limits in different types. This is one of the interesting ones. And the reason why I call my channel Lecture Notes, or Lectures with Notes, and not just solving problems or math problems, it's because I like sometimes to write notes, clear up notes, show you more details about what's going on as a lecture, not just solving the problem. Let's get started. To find the limit, as stated, limit of e to the power 3 over 5 minus x, as x approaches 5 from the left. I need to show you more about transformations and what's going on with the reciprocal function. Because the main thing right here is, if this is just like regular x, it will be easier to solve. And usually x approaches infinity or x approaches negative infinity. But in this case I have more details. I have x approaches 5 from the left, and the exponent here is a function that relates to the reciprocal function 1 over x. Before we start, as an introduction, let's talk about the vertex form and transformation using the vertex form. We know that y equals x to the second is a parabola that starts right here. The vertex is 0, 0. 1 will give you 1, 2 will give you 4, negative 1 will give you 1, and negative 2 will give you 4. It's just a basic parabola, second degree function. Now, if I write the vertex form, if you notice right here, the function is going to be graphed in this color. We have a as the leading coefficient, determines if the graph opens up or down, and if it gets stretched vertically by a factor of a. If a is 2, it's going to be stretched vertically. If a is half, it's going to be compressed. Now, this right here is the amount that tells you how far you're going to go right. And this k is going to tell you how far you're going to go up. Of course, if k is positive. If k is negative, you're going to go down. If the value of h after the minus sign is positive, you're going to go right. If the value of h after the minus sign is negative, you're going to go left. So, just a basic, simple example. I'm going to use a equals 1, so there is no vertical stretch. And h equals 3, that means we're going to go 3 units to the right. And k equals 2, that means we're going to go up 2. So the graph will end up the following. The vertex will be 3 and 2, which is h and k. That's the vertex. And the graph will be as follows. It's the same graph. So if you notice right here, it's 1, 1. And we still have the 1, 1 concept. So it's not vertically stretched. It's not. And the vertex is 3, which is in red, and 2, which is in green. That is the vertex, 3, 2. Now that helps understand the transformation, especially of the form that we have 1x inside minus something. Let's move on. Now the limit that is given to us of e to the power 3 over 5 minus x is related to the reciprocal 1 over x. Understanding the basic function of the reciprocal, that will help me understand 3 over 5 minus x. So, first let's call the function 3 over 5 minus x I of x. This function, I want to graph it, but to graph it I want to go slow as a lecture, showing you more details about where it's coming from. Here's 1 over x. 1 over x is called the reciprocal function. If you plug in 1, you get 1. If you plug in 2, you get half. If you plug in 10, you get 1/10. 100, 1 over 100. It gets smaller. And if you plug in 0.1, it's going to be flipped to be 1 over 0.1. That's 1/10. It's going to flip again and be 10. So we know the graph. It's just like this right here. Negative stays negative, positive stays positive. So we are in the first quadrant and the third quadrant. As I mentioned, plug in 1, you get 1. Plug in 2, you get half, and so on. And if you plug in a decimal, it's going to be flipped and it's going to take you up right here. So that's 1 over x. How about if I multiply the whole thing, 1 over x times 3? 3 will show up on top as 3 over x. So this is 3 over x. So the graph is going to be stretched vertically by a factor of 3. As you could see right here, 1 will give you 1, but this time 1 will give you 3. Because if you plug in 1, you get 3 over 1, which is 3. 1 gives you 3. That's this right here. Same look, same shape almost, but stretched vertically by a factor of 3. How about if I multiply or interchange x to minus x? The idea when you change x to minus x, you are looking at xy axis. Instead of being here, you're going to be here. Instead of being 5, you're going to be negative 5. 6, you're going to be negative 6, and so on. That is a horizontal reflection about the y-axis. So this right here will end up to the left, and this right here will end up on the right. That's if I change x to minus x. Now, what's happening right here is it's not 3 over minus x. It's 3 over 5 minus x. So we need to know what is 5 going to do to it. But I'm going to combine the idea of 5 with the vertex form. So if x equals 4, I have 3 over minus 4 minus 5, which is 3 over negative 4 minus 5, which is negative 1, 3 over positive 1, which is 3. So 4 gives me 3, and that is right here. Just to support that, we have to go right 5 units, not left, because for some reason this is confusing some students. They think that it's like minus x plus 5. They're thinking that plus 5 will take me to the left 5 units, but you have to write it this way with x by itself, just like the vertex form. I think that's good enough to understand the graph of 3 over 5 minus x. Let's move on to the main part. So, to summarize what's going on, that's the limit that we need to understand. And we know now how is the graph of 3 over 5 minus x. That's going to be called u. So my function is u equals 3 over 5 minus x, which I said the right way is to see it 3 over negative of x minus 5, and the graph was stretched, reflected about the y-axis and shifted to the right 5 units, and that's what we came up with. Now if I change this and I rewrite it as u, the problem becomes limit of e to the u as x approaches 5 from the left. But we can't have a u here and x here. We need also to handle this part right here and change it to the u language. How do you do this? As x approaches 5 from the left, this is 5 right here. As you approach 5 from the left, not from the right, what happens to your function values? You're gonna go all the way up. So this u function that is graphed right here is gonna go up to infinity. In short, without having this in our way, we could say that as x approaches 5 from the left, u, which is graphed right here, is going to go up to infinity. So I could replace this now with this right here. And now this becomes limit of e to the u as u approaches infinity. But usually we don't see it we see it as e to the x. So that we see it as limit x approaches infinity of e to the x. That is right here. Limit e to the x as x approaches infinity, we know that it's an exponential function and it goes to infinity. So the answer to our problem is infinity, and that should do it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.